Welcome to lesson 4.5. The title of this lesson is Reflections and the Square Root Family. Our objective is to write equations for a reflective functions including lines, parabolas, and square root functions over the x and y axis. By definition, a reflection is a transformation that flips a graph across a line, creating a mirror image of the original function. You will be introduced to a new family of functions, and that's the square root families. But reflections will also work for a line, parabolas, and square root, and ultimately we should be able to use this towards more functions in a later lesson. So let me introduce to you the square root family. The original parent function of a square root family is y equals to square root of x. Let me choose some x values and then calculate the corresponding y values. If I allow x to equal to 0, you're looking at the square root of 0, which is also 0. When I allow x to equal to 1, you're looking at the square root of 1, which is also 1. When I allow x to equals to -1, you're looking at the square root of a -1, which does not exist at this point. When I allow x to equals to 2, you're looking at the square root of 2, which is approximately 1.41. When I allow x to equals to -2, you're looking at the square root of a -2, which does not exist at this point. I can continue to choose x equals to 3 and -3, but that is a little bit more difficult to graph. So I'm going to choose some x values that I know the square root of. For example, I'm going to allow x to equals to 4. So then you're looking at the square root of 4. And I do know that square root of 4 is equal to 2 at this point. Right. When I allow x to equals to 9, I'm looking at the square root of 9, which is a +3. I can continue with this trend and choose x to equals to 16. So then y is the square root of 16, which is 4. Let me plot these on my graph. When x is equal to 0, y is 0. That's the first point. When x is equal to 1, y is 1. When x is equal to 2, y is 1.41, which is probably approximately right there. When x is equal to 4, so 1, 2, 3, 4, y is equal to 2. And when x is equal to 9, y is equal to 3. Now, you will notice that I cannot take the square root of a negative number, so therefore x, the domain for x is only on the positive side of the equation, right? So let's talk about a couple of things. The first thing I do want to talk about is domain, right? In this particular case, x has to be greater than or equal to 0. I'm sorry, I don't have a greater than equal on my keyboard. For the range, it will also be greater than 0 at this point. So here are my domain and range of this parent function of y equals to square root of x. It's half of a Skyway parabola. And the reason why it's only half is because if we allow the bottom half of the Skyway parabola it will not pass the vertical line test, and therefore it will not be a function. Right? So again, this is the original parent function of y equals 2 square root of x. All right. My question for you is, what happens if I take this square root of x function and I move it up, let's say 3 units? All right. Think back in lesson 4.4. Okay. How do we transform this equation so that it's reflecting the fact that it's moving up, translating up 4 units? And it will work the same way as a parabola. The new equation would be y equals square root of x I couldn't find square root of x key on my calculator, on my computer, so I'm going to just have to write it. So this is the same thing as square root of x and then plus 3 on the outside. Okay. Now, same thing would have happened if I translated down, let's say 3 units. If I was to translate it down 3 units, it would be square root of x, and then minus 3 would be outside. All right. Now, what if I want to move it to the left 4 units, for example? So it looks like that. Right. If I want to translate something to the left 4 units, all I have to do is replace x with x plus 4. So it looks like something like this. Y equals the square root of, and it has to be x plus 4 together inside the square root sign. And because I'm not moving it up and down, it will remain the same. So the translation of this function up and down, left and right, is very similar if I was to translate a parabola. So here's a little bit of a summary for what I just said. If I happen to have y equals square root of x minus h, the h again has to be inside the square root sign, and then plus k. Right. If I happen to have a plus k, I'm moving the vertex up k units, however many unit that is. All right. If I have a minus k, that's moving it down k units, whatever that might be. Same thing with this, all right? Keep in mind that the signs are opposite. So if I happen to have an x minus h, I'm actually moving it to the left. If I have an x plus h, I'm moving it to the right. Okay. If we were to sketch this function, y equals to square root of x minus 2 plus 4, remember, the original function is 0, 0, 1, 1, 4, 2, and 9, 3. This is the original function, and I apologize, my mouse is not drawing this very well, but it's supposed to be a sideway parabola. If I want to translate that into this new function, that x minus 2 tells me that I want to take this function and move it to the right 2 units. So wherever the vertex used to be, it used to be at 0, 0, will now be moved right 2 units, so it would be here. However, we're also shifting it up 4 units. So that would be right there. Right. And everything else remained the same. So it'll be up 1 over 1, up 2 over 4, and continue on, which is outside of my graph. So this is what that new function would look like, with the graph being translated to the right 2 units and up 4 units. Let's do one more just to make sure. If I happen to have this, I know it looks kind of different, but the minus 3 is just the same if I wrote it first versus if I wrote it at the end. So my original function, again, used to be at 0, 0, up 1 over 1, up 2 over 4, and then up 3 over 9. So that's my original function. This new translated function will be shifted to the left 6 units and down 3 units. Okay, so let me take the vertex, shift it to the left 6 units and down 3 units. So up 2 over 4, up 3 over 9, 2, 4, 6, 8, 9. So that's what my new translated graph looks like. And again, I apologize for the sketch, but I think you got an idea. All right, stop the video and please go through the investigation. It is step-by-step instruction. Please don't skip anything. And tomorrow during class, we will cover the ending of the